webinar. Today we're going to talk about oil primary controls, and these are our ICM 1501, 1502, and 1503. Probably a good way to start is where are these things used and what is an oil furnace? So an oil furnace works by burning fuel oil in a combustion chamber. The heat created is transferred to the air passing through the heat exchanger and blown into your home. The fuel oil is stored in a tank that looks like these. We've all probably seen these big oval tanks. Typically, they're outside. This picture has it in a basement and had a furnace attached. So I thought I would use this to to show what these things are. Actually, this is a hydronic. This is a boiler, but fuel oil is stored in the tank and then it's pumped into the burner assembly. And that's really the only thing we interact with is the burner assembly. Heating oil is dyed red to distinguish it from diesel fuel, very similar to diesel fuel, and would normally be a champagne color, kind of like diesel fuel. But actually, they dyed diesel fuel green. They dyed heating oil red. And as I was kind of reading up on some of this, the IRS is actually the department that forced that to prevent tax fraud. So, must have been a pretty big difference in price between heating oil and diesel fuel. So they did that to keep us all honest, because they don't bring in enough revenue. So they need to make sure to keep us honest. What is an oil primary control? So an oil primary control is a startup and safety intermittent ignition control module for oil furnaces that works in conjunction with the cadmium sulfide cell, or the CAD cell. The oil primary control responds to the thermostat, limit control, and information from the CAD cell regarding the presence or absence of a flame, and controls the operation of the oil burner assembly accordingly. So the CAD cell is a flame detector in an oil furnace that senses the presence or absence of a flame. The CAD cell is a photoconductive device that changes its electrical resistance based on how much light it receives, and then sends that signal to the oil primary control. So this is basically what we're interacting with is the burner assembly itself. So you've got a fuel pump. So oil comes in from the fuel tank. Fuel pump, air inlet, motor. There's also a little solenoid there, a transformer on top, and then the primary control. And then you've got a blast tube, nozzle, electrodes, and so on. And we'll show you how this thing works. So what oil primary controls do. So the thermostat calls for heat, and the oil primary control checks with the CAD cell. Hey, do we have any flame in the combustion chamber? Because if there's already flame in there, you don't want to ignite, and cause some kind of a flame situation. So it confirms with the CAD cell first. Okay, there's no flame present, so it's okay to send the signal. Sends the signal back to the oil primary control, says everything's okay. Then the oil primary control makes a connection between the T terminals. And then that sends 120 volts to the transformer in the burner assembly. So this is the CAD cell. If you can see my cursor, these two yellow wires, this is the CAD cell that's sensing the light from a flame or the absence of light, and then is sending that signal through those yellow wires to a couple of terminals on the front of the oil primary control. And then this is the transformer in there. The transformer, in turn, then sends 20,000 volts to the electrodes or the ignition rods in the burner assembly to ignite the oil. And that's these two rods up here in the top. So what this part of the assembly actually flips back over and closes up on there. And so you see these springs. That's what's sending the voltage to those flame rods and or ignition rods. The oil primary control also at that time, it sends 20,000 volts here. It also sends 120 volts to the motor, this motor in the burner assembly. which pumps oil and draws air. That starts the fan and it draws air, pushing it forward to support combustion in the burner chamber. It also powers a solenoid that starts and stops the oil flow based on the state of the motor for added safety. So this is a little solenoid there that will open or close based on the action of the motor. The CAD cell detects flame failure or loss of flame in the oil primary control, and then shuts the system down. So if there's a flame failure or loss of flame, system shuts down, oil primary control will shut the whole thing down. So this is a little closer look of what's going on inside the burner assembly itself. This doesn't really show the controls in there, but basically the F terminals are flame, T terminals are thermostat. So call for heat, and it goes to the F terminals and says, hey, CAD cell, are we okay? Is there any flame in here? CAD cell says, no flame. And then oil primary control says, okay, let's make this circuit here and send that 120 volts to the transformer, which sends 20,000 volts to these electrodes inside the ignition rods. And then it starts the motor and the fan, and consequently then pumps oil. So now we've got oil coming up the line from the tank, and it's going to continue up into the nozzle. And with these things fired off at 20,000 volts, you've got some air pushing through, and it's pumping oil, and it sprays out this nozzle. And then as soon as it comes out, that 20,000 volts ignites that oil with the air pushing through, and off you go. So where is heating oil? What are the heating oil applications? So it's used in both residential and commercial. Oil-fired boilers, probably the main source for oil-fired stuff. Hydronic heating. So hydronic heating, everybody's seen these radiators pumping hot water through the radiator to heat a room. Some parts of the country that's very, very popular even still. Oil-fired furnaces. So this is like a forced air, like a regular furnace, like a regular gas furnace, but they're just using this oil burner assembly in there. And then fan blows hot air off the heat exchanger in the oil-fired furnace. Same principle as a gas furnace. Oil-fired water heaters, a lot of those out there too in those markets. Oil-fired space heaters. This is unit heaters in commercial applications. We've all seen them, right? Hanging up in especially large spaces, warehouses, that kind of thing. Oftentimes they'll use these unit heaters to accomplish heating those large spaces like that. Other types of space heaters, we've all watched NFL games and you see them pull these gas-fired or these oil-fired torpedo furnaces out there. And these things are just blasting heat out there for the players on the sidelines in very cold temperatures. I'm sure it's used in construction and, a variety of other applications as well. And other oil burning appliances. There are other things out there that utilize that technology. Where is heating oil used? And it's primarily in the Northeast. So these are areas where they have limited access to natural gas. Cold climates, particularly in the Northeast. In 2021, DOE says 82% of heating oil sales in the United States came from residential consumers in the Northeast. So that's a pretty considerable stat. And so most of it is up here, and Alaska also was really big on heating oil. Oil heating is also used for drying tobacco in flue curing barns. I've heard that for a long time. So that would be Carolinas, maybe some of that area. They use oil heating for drying tobacco. And some of it looks pretty old school. If you go out there and look at pictures on the internet, it's pretty interesting. But we have 3 different models, 1501, 1502, 1503, which have a different delay and will replace different models. But the 1501, 15-second delay, 1502, 30-second, and 1503, 45-second. 1503 is the most universal of the three. Changes out the majority of stuff out there. So in the event of a lockout, pressing and holding this red external reset button up here for 3 seconds will manually reset the safety switch. For added safety, what we've done is the action of the button press is activated when you release the button. So that way it'll ensure that the button can't be just permanently held in. So a status indicator LED on the control board. There is a status LED nestled right down in here. And that status LED indicates the function of the control and can be used to aid in testing and or troubleshooting. So to initiate a manual lockout of the system, press and hold the reset button when the status LED is off. There's a slight delay before the heat call is implemented. This is to verify the call is valid. So intermittent oil primary features and benefits. So this controls the oil burner, oil valve if desired, and the ignition transformer in response to a call for heat. Solid state flame sensing circuit. LED on the terminal strip indicates system lockout or system condition. Enclosed safety switch with external reset button. This thing mounts on a standard 4x4 J box. Select models, you can mount it directly on the burner housing. Works with this cadmium sulfide flame detector, a C554A, and a thermostat, and those are required to be there on the system in order for this thing to interact and work with it correctly. And most have that, so no biggie there. But direct replacement for popular competitive models. Specs, it's an intermittent ignition module. Timings, like I say, 15, 30, and 45, mounts on that standard J box, and has all the UL approvals. These electrical ratings and stuff, check your specs to see, but it's a suitable replacement for all these models. So here's your cross-reference. 1501 Honeywell Residio, those are 8184G series. There's a ton of those out there, different models, and we replace. So again, fewer SKUs, more turns for the distributor. Why stock 4 different modules when you can replace them with one, or in this case, several more. Carlin, Honeywell, Temp, Star Heil, White Rogers, Emerson, replaces a number of different things. So like I say, the 1503 is the most universal of the bunch. And then wiring. So any questions so far or any thoughts? Probably cover everything. Fairly straightforward. It's a fairly simple control. It's a very important, what it does, the function of the control, but it's very, very straightforward. So you've got basically 4 terminals on it. You got the T terminals for the thermostat. You've got the F terminals for the flame sensor, and those are those yellow wires that come from the CAD cell, and they're going to talk back and forth. So that C554A, you just hook those wires up there, and the 2 controls work in conjunction with each other. And the thermostat will, talk to this control as well. So basically, you've got black, white, and orange coming out of the back, and that's L1 and L2. And then the orange wire, once the CAD cell tells the control that it's okay to fire off, connection is made between the T terminals, and then power is sent down that orange wire, and we'll perform the sending the 120 volts to the transformer, which sends 20,000 volts to the ignition rods. It'll start the motor and the oil valve. And so all those things are controlled by that one orange wire. So you got 3 wires off the back, L1, L2, orange wire to power everything up. And then the flame terminals constantly monitor, the CAD cell constantly monitoring the flame. If there's any interruption in the flame, this control will shut the system down. And you can use this with a low voltage thermostat. 24-volt thermostat hooks up on the T terminals. If you're using a line voltage thermostat, you simply hook that in series with the limit switch and jumper the T terminals. So that's it pretty much on the wiring of the device. Then the reset button. There's instructions on the control itself to tell you how to utilize that reset button. Troubleshooting, very straightforward. Again, there's a status LED indicator that will tell you what's going on. So LED off, no power to the control, no called TT or normal operation. LED is solid. The CAD cell indicates no flame or a lockout condition. So again, safety device, transmits power only when everything is secure and safe according to its information it's getting from the CAD cell. We give you a detailed rundown, a checklist to just work right down to troubleshoot what the problem is. We even tell you how to check the CAD cell. So very, very simple and straightforward control. Let's see what else we got. So let's talk about the universal parts advantages. So ICM has really put a lot of time into developing universal parts for contractors, for everyone. It works well for ICM. Fewer SKUs, we can produce more in a shorter amount of time, less changeover in production. So that works really well for us. Then for distributors as well, ICM has always made top quality products. So distributors are getting a quality product, able to reduce their inventory, the number of SKUs that they have to carry to cover, applications in the field. Fewer SKUs, more turns. Everybody wants this. And it's good for everybody. The chances of you going to a distributor and finding something that will work on the job is increased by having these quality universal parts. And single U.S. source. We're in Syracuse, New York, have been since 1984, and just manufacture top quality products. High manufacturability, like I say, ICM through supply chain issues really went back to work. We engineer everything in-house in Syracuse at ICM, and they put a lot of time and effort into really evaluating the products, challenging the products. Is there a newer component that's more readily available in the world that I can use to manufacture these products? Can we streamline it, make it more manufacturable? And we've done that with all the product line, everything in the product line. And so they're more manufacturable. We can make more in a shorter amount of time. Versatile on-hand solution. ICM is a very popular brand, and it's been out there for a long, long time. And so we sell everybody pretty much something. So distributors often will specialize in a certain product area. And so you'll be able to find ICM products on the shelf at pretty much any distributor. And if you don't find it the first place you go, then just go down the street and you'll probably find it at the next guy's supply house. The universal products, though, are designed so that you don't have to make trips back and forth to the distributor. For contractors, again, you're getting a quality product. Truck space is limited, so it's better to have some universal products that will take care of the job, even if you're out, in Timbuktu somewhere. You're going to have something on the truck that chances are you can make it work. Reduces trips to the distributors. Widely available, like I say, through our network of distributors all across the country. Easy to install. We try to keep it simple, and we're always competitively priced. So ICM at this time, and I might even be missing a couple items, but we have universal time delay that is amazing. The ICM UFPT5 Universal Function Programmable Timer. Universal furnace board. ICM 2812 kit replaces like 219 different furnace makes and models. Ignition control module, the ICM2918, that replaces almost 300 different ignition modules, spark ignition modules. And then the universal head pressure control replaces all single phase head pressure controls. Our legacy models are all replaced by this universal head pressure control, and just about everything in the field that has ever existed in the head pressure control market. ICM is definitely the leader in that particular product, and this thing will work with 2 temperature or 2 pressure probes, and it's a universal voltage, very easy to set up utilizing NFC programming technology. Same with the time delay relay. And then universal hard start from 12th horse to 5 ton, which utilizes our universal potential relay on top of a capacitor. So it's a universal, it's differential voltage sensing. So it only stays engaged as long as is necessary, and then it drops out. So it's a great hard start and the potential relay, because it's not going to just take the energy that's in the capacitor and dump that on the windings every time. It's only going to deliver what's necessary, and then once it senses that the motor has started, it drops out. So real brilliant technology. ICM Controls will continue to provide new innovative products going forward as well. And we do have preseason going on, so if you are a distributor or if you're a rep, please, if you're a rep, get this information out to the distributors so that they can take advantage of the tremendous savings, really, on a lot of these products. It's time to stock up for winter. Certain parts of the country are starting to cool off quite a bit. We're in the shoulder seasons, and a perfect product for that is this universal head pressure control listed at the top. And you'll see that some items are listed as a featured item to qualify for additional discounts and that type of thing. But these 3 right here are really flagship items for us. Universal head pressure control, our single phase surge protector, the ICM517, is an industry leader. It is the best in class in the industry. It's really the highest quality product out there, with an extruded aluminum housing and the highest ratings, the highest surge protection rating allowable by UL. And then the universal function programmable timers, especially that UFPT5. It replaces 85 of our legacy timers, plus you name it out there in the field. It can be a delay on make, a delay on break. It can be a duty cycle timer, a single shot timer, a bypass timer. You select what you want it to be using that NFC program. It's really, really awesome stuff. A shot of a portion of the facility out there in Syracuse. These people do a great job in production, and they test every item that we make to ensure that it's working when it leaves the building. So any thoughts or questions regarding oil primary controls? As always, you can go to the ICMcontrols.com website and look at our media library. If you need product spec sheets, you need information on the product, you can go in there and read everything you need to know about it on the product page. There are QR codes on the boxes as well, so you can scan it with your phone and it'll take you right to the page where that product lives. You can read up on it. There's cell sheets, spec sheets, there's installation guides, a lot of supporting information. If there's an installation video on that product, there's usually a link right there on that page, so you can get all the product detail that you want. And cross references, there's PIM data, all the information that you need to set these things up in your system and figure out what they replace. We also have a fantastic tech support department. The people internally there are very, very well versed on our products and can troubleshoot in the field for you, are always willing to help you anytime. If you have some really detailed technical questions, you can talk to our engineering staff, and they'll tell you how these things tick, from inside out. So fantastic product, great company, and definitely wish them well moving forward. Thoughts, questions?
Well, Keith, I'm Matt here. I just wanted to say thank you for your many years of service and friendship. And, we respect you very much and look forward to your enjoyment of retirement. So thank you.
Woo-hoo. Yeah. Yeah. Thank you, Matt. I appreciate that a lot. All right. Well,
Keith,
thank you everyone for.
Man. I'm sure you're going to pop up somewhere in another couple of years doing something here, though.
Yeah, somebody may drag me back in, but I doubt it. I'm gonna go relax and play for a while. So we'll see how it goes. My wife is gonna continue working, and so if we start running short on dough, I'll see if she'll volunteer to get a second job or something. Not right, I know. No, she's a great little lady. So
of course.
Thank you, Keith. Enjoy your retirement.
Thank you very much. Appreciate it.
Take care. All the best.
All right, you guys take care.
Okay, thanks, Keith.
Okay, see you.
Okay, talk to you later. Bye.
All right. Bye.